Thank you. Welcome, everybody. I'm Grayson Randall on behalf of IEEE and the IEEE Humanitarian Technology Board. We welcome you to the session today. If you were here yesterday for the use cases, welcome back. I hope you found the sessions were insightful. Today should be a very exciting day as we go through the platform and the work that we're going to do there. If you need any of this information from yesterday or from today, you can always go to the IEEEHT.org website. All the information related to the competition will be found there. So, should have an exciting day today. I'm really excited to see an international audience here to participate. And I'm going to pass it off to David Manset from the ITU to go through the activities for today. David?
Thank you very much, Grayson. So it's a pleasure to welcome you all to this second info sessions on the technical framework that will support the challenge. So today we'll have an extensive set of presentations from the team with David Forden, Roman Chesnov, and Bilge Yücel, who will provide you with more information on how to get started with the challenge and basically how to technically integrate the framework that we are offering for this challenge to make it possible to develop quite quickly scalable applications based on generative artificial intelligence. So we are here as ITU to support you throughout the challenge. So we will be making sure that you have access to all of the technical support and information that are required to develop your various applications. Yesterday, we had the first info session with the free use cases where you had the possibility to discover what we are expecting from the participants. So the context into which your innovations will be welcome for the different sectors and countries at stake. It's open to everyone. The interesting commonality between the three use cases is that you will all be developing under the same technical framework. And in particular, a framework that has been nurtured and that has been growing for the last 2 years, coordinated by ITU, which is called GENIE.AI, where the objective is to consolidate and capitalize all of our related developments on generative artificial intelligence, all this truly open source, such that our member states can benefit in the future. So in the present challenge today, we'll touch on GENIE.AI, how to access its API, how to plug in your own developments, how to extend that framework. My colleagues will also dig deeper into the enabling stacks of this framework, such that you have an exhaustive understanding of the framework. And so we hope that this will be helpful and you will have sufficient information to embark into your thinking for your respective applications to the challenge. As a reminder, we are expecting innovative solutions for the free use cases that were described yesterday, whereby your solutions do integrate the framework. You're free to bring in additional open source resources. You will have to deliver truly open source your respective solutions. But we are expecting really high quality contributions to these developments with good documentation. The objective is not just developing something, it's really making an impact. So we have selected countries and use cases in which we have real concrete requirements on the field. So we do hope that you will address the challenges and come up with really innovative and high quality solutions, especially as you will be given not only time to develop, but also time to scale in country and to test your solution in real settings. So we'll be expecting from you concept, design notes, high-level architecture, and information, all potential information on implementation risks, impact measurements, in the technical approach that you have taken in your ideas. So with this, I would like to say good luck to everyone and to pass the floor to David Forden, who will speak more in details about the GENIE.AI technical framework. David, over to you.
Yeah, thanks very much, David, and also thanks for Antonia and Grayson introducing us. So, as David said, my name's David Forden. I'm just going to share a deck of slides here to get us going. So, give me just a second for that. So, I'm assuming everyone can see the deck of slides now. So, we're expecting a couple of other people to join us to help as well. So, I've also got with me Roman Chesnov. So, Roman's the back-end architect for GENIE.AI, and we've got, I know Bilge Yücel is here. So she's from the Haystack team. She can answer questions about Haystack. We're expecting a guy named William Fowler. I haven't actually seen William yet. William should be here to answer questions about OPEA, which is one of the frameworks that's incorporated into GENIE.AI. So essentially in this session, we're going to equip you to understand our architecture, how to prototype what we call RAG applications, which is kind of a bad acronym for AI-driven search with GENIE.AI. We're going to cover the stack. We're going to dive into some of the extensions that we've made for frameworks like OPEA. And to be very clear, there's no intent for anyone to start coding immediately. We just can't support any developers during phase one. So our expectation is that you'll use the information shared in this session to help you put your proposals together. And if you decide to clone our repository and go for it, then you're welcome to do so. Of course, it's open source, so nothing to stop you from doing that. After we cover the technology details, we're then going to give you an overview of some of the roadmap items that you can consider as part of your proposal. So David talked about innovation a minute ago. So there's sort of two aspects to that. One of them is helping us to deliver on specific innovative items that we want to build into our framework in the roadmap. And the other side of it is what David talked about briefly, which is all about your actual use case solutions. So essentially, if you decide to deliver on the roadmap items, it's going to help your team score higher and get closer to the prize. So I've included links to the mirror of the repository here. So feel free to have a look through the code. And later on, I'll actually be sharing this deck. So there's a number of links through the slides. I'm not going to touch on everything because there's just not enough time in this session to do so. But in the meantime, to start the session, we're going to conduct a quick demo of the MVP that we've built, or the minimum viable product that we built with the GENIE.AI framework. So this is going to give you a sense of what can be delivered. So in that context, our goal set for the framework project is to actually enable developers to deliver new basic public services as a chatbot with a lot of reliability, and do that in a matter of days or weeks, not months. So without any further ado, let me just fire up the MVP application. So I'm hoping everybody can see this. So we've got a complete framework built. It handles all the security. So if you want to do things like account registration, you can do that through here. We can go back to the login screen if you've maybe forgotten your password as well. There's a password reset screen and so on. So I'll go back to the login here and actually log into the app. So one of the things that we're building on the roadmap is social login. So that'll be utilized probably with Google and Facebook and so on in the interim. So this is the main screen of our MVP. So this MVP was built as a like a demo environment for a project in Kenya. So this particular instance has been primed with a whole lot of data that is relevant to that specific public services use case in Kenya. So this application being built with a framework is very adaptable. You can see all the buttons here in the middle. These are all configurable. So if you want to implement new buttons with different logos and so on, you don't need to be a developer to do that. You can simply reconfigure the application interface through a configuration file in the background. And on top of that, each one of these buttons has a specific link associated with it for crafting a prompt that goes to the AI backend. So, for example, if I want to maybe apply for an ID, you can see that a prompt's been automatically run there, and it's going to the back end. This is not running on a very big infrastructure at the moment, so it's not extremely responsive. As you can see, we've got a decent response there telling me that if I wanted to apply for a national ID card in Kenya, I'd need to follow these steps. So gather the required documents, visit the NSSF office, the application process, and then if I wanted to do that registration online, I could do that. So I'm not going to demo too much in terms of follow-up questions, but if that was something very life-changing for me, or I wanted to give some feedback, I'm well within my means to do that here, so I can maybe add some additional comments to this to help the people that are administering the application and submit that feedback. This is an important feature when you're deploying a chatbot because you're going to need to have the ability to run some analytics on what's going on with the various different people using the app to understand how well it's being received and the things you need to adjust along the way. So on the left tree side here, you can see a tree. So this is to do with our labeling system. We call it knowledge areas. So we'll talk about this in a bit more detail afterwards, but essentially, this is one of the key features of the solution framework that we've built. The second tab here has existing conversations. So the way that we've built this is that you can store any particular conversation literally, say down the bottom here by clicking the save button as a particular. I'm not going to save this one, but you can save a chat or a conversation and name it and so on, and then from there you can call it back. So you can see I can now, whoops, let's just do that again. So I'll try and reload this one. Yeah, there we go. Okay, so you can see that's pulled back a conversation that was around museums and so on. So we've got a lot of features that we built into an administrative module as well. So it covers pretty much everything from like a systems overview to, configuring that knowledge hierarchy on the left to managing documents. So rather than having you have to go through the pain of a lot of technical data ingestion into the RAG solution, we've actually built a system whereby you can ingest documents into the system by simply uploading them and labeling them. So for example, if I wanted to click on any particular document, maybe this particular FAQ here, you can see it's been labeled with in this case parks and recreation, wildlife, and tourism, and it's been ingested. So that the system is actually able to answer questions based on any of the documents that get ingested. We've got a user profile module. We've got some basic, system settings and so on to run different themes, and you can change your email address. All the basics are there. So there's really not a lot that needs to be built on top of this, other than the specific features and also the base of data that you're going to use to train, or not so much train, but prime the solution with the relevant information that has to be there for the AI-driven search mechanism. So I think we really need to drill through some more slides now, because it's going to be quite some there's going to be quite some time spent on these things, and so basically this shows like a high-level view of the GenAI framework and the principles that are used to build it. So some of the details that also need to be they really need to be understood in order to deploy this. So in the interest of time, I really can't cover every detail. To be 100% clear, there's quite some reading to do in order to get familiar with this. But once you've done the reading, etc., that should be pretty smooth sailing to get working. The intent of this session is to really give you enough detail to design solutions to the use cases and prepare your proposals from a technology perspective. So we'll actually make this deck available, like I said, with all the links related after the session. So moving right along, what we have with GenAI is a platform designed to help governments deploy and run AI chatbots in a way that's very secure, it's sovereign, and it's citizen-focused. So this initiative is grounded in global standards and commitment to using the technology for humanitarian good. GENIE.AI is about empowering public institutions to build next-generation digital public services. So the core capabilities, or the what, if you like. So firstly, digital sovereignty, which is crucial. GenAI enables the deployment of AI services on a nation's own sovereign infrastructure, or alternatively on cloud. So what this means is that the government can retain full control over their data, their AI models, and everything that's essential for security and public trust. Secondly, seamless integration. So the framework's designed to run either standalone as a deployment or integration with another project called GovStack, which has a large government building block style architecture. So this ensures that the application can actually interoperate smoothly with existing digital government systems. Thirdly, scalable deployment. So governments really their needs vary greatly. So our platform offers flexible deployment options that make it suitable for everyone from a small local municipal government up to a very large national government to deploy. The fourth principle is around citizen-centric services. So the ultimate goal here is that we enable natural language interfaces for all government services. This means that citizens can interact with the government as easily as making services both more accessible and user-friendly. Finally, agentic automation. So this is a roadmap item for the framework, but the goal for us here is to move beyond simple chatbots to automate complex multi-step government workflows. So this helps to increase efficiency. It helps to free up resources. And it's going to be something that we're also going to be talking about during the roadmap items. So the guiding principles essentially, or the how, if you like. So we built GenAI essentially as a development guided by these 5 fundamental principles. So firstly, it's fully open source. So this ensures transparency. It prevents vendor lock-in. It allows global community of developers and governments to collaborate and improve the platform together. So in that context, part of the outcome we're seeking from this challenge is to try and get more people actually involved in the core project. So that's a potential opportunity for all of your engineers and developers going forward. Secondly, security, privacy, and reliability, they're paramount. So when dealing with government services and citizens' data, there's really no room for any compromise. Our architecture has been built from the ground up to be robust, trustworthy, secure, scalable, and available. So we're focused on really also lowering the costs and administration by using open source technology designed for efficiency. We aim to make advanced AI accessible and manageable for public sector budgets in the global South countries, which is always a challenge. The platform's built for collaboration and exchange, and we envision a world where governments can actually share best practices, share service designs, and accelerate their innovation for everybody. So underpinning everything is a deep commitment to ethics, standards, and transparency. We're very dedicated to building responsible AI that's fair, accountable, and transparent. So just now we introduced our vision for AI in government. Let's put that in a bit more context and get more specific about the layers. So when we say AI, that can actually mean a whole lot of different things. And I'm sure that everyone on this call has been bombarded on maybe Instagram, Facebook, with all sorts of interesting messages on AI. So there's a massive kind of I guess a bubble that's really been built up over the last 2 years with AI. But what we want to try and do here is just sort of bring it down to earth and drill into exactly what we're talking about. So what that comes down to is understanding what RAG is in the world of AI. So on the left, you'll see the confluence of related AI technologies. So at the highest level is AI itself, which is a very broad field, as I said. Within AI, we've got machine learning, where systems can learn from data and make predictions. Then generative AI, which is a very powerful subset of AI. Essentially, that's the technology behind systems like Claude or Gemini or ChatGPT, if any of you have used them. So this allows users to create new content using AI, like text, videos, images, or code. So overlapping all of this is NLP, or natural language processing, which allows computers to understand and process human language. So the specific technology we're focusing on with GENIE.AI is retrieval-augmented generation, or RAG. So this is a technique that sits at the intersection of generative AI and NLP. It provides literally generative responses for chatbots that are accurate and grounded in more factual information. So the reason this exists is because just relying on an LLM, if you like, or a large language model is not enough to build a chatbot that provides that grounded factual information. This is where RAG is actually essential, and why it's a game changer for government. So that's what RAG is. Now, the most important question is, why RAG? Why this specific technology is so critical for the public sector? So the answer to that starts with the foundation. So public institutions are they're the primary owners of the citizens' data and a lot of other data in any country. The problem is that this data is often siloed or stovepiped, if you like, and also unstructured. It's locked away in various different repositories, in PDF documents, Word documents, legacy systems. It's very difficult to search, and the systems often enough don't talk to each other. There's been multiple attempts over the years to solve that problem with data lakes and data warehouses and so on. But essentially, that situation has never really been resolved that well, and it makes it almost possible to extract valuable insights. So this is where RAG, which is also known as AI-driven search, comes in. So RAG acts as a crucial bridge to this. It's a technology layer that can intelligently search and retrieve relevant information from a massive pool of unstructured data. It then augments or provides the retrieved information to a generative AI model as a context. In simple terms, RAG allows the AI to look up facts from official sources before it generates an answer. And that's a very important thing to understand. So this capability unlocks a lot of potential and opportunity to improve efficiencies, deliver better services. So with RAG, we can power a whole new suite of public sector applications. So we can build chatbots that provide citizens with accurate, verifiable answers. We can do things like automate document processing to speed up some of the reviewing of applications and generating of reports. We can do things like enhance workflows and handle more complex tasks in a procurement or recruitment environment. And we can do things like enable real-time analytics and monitoring to give the business leaders or commercial or even the institutional leaders, if you like, up-to-minute understanding of what's actually happening based on the incoming data. So RAG is really the key that unlocks all this value and the focus of what we built with GENIE.AI. So we talked about the what, we talked about the why. Now let's take a quick look under the hood at the how. We've built our GenAI framework on a robust open source tech stack. We've chosen these specific technologies to ensure that our system is modern, scalable, and secure, as well as avoids vendor lock-in. So the foundation in the center is, you could think of this as like a central cloud. So everything starts with a solid foundation. This is our core infrastructure tier. It's built using cloud-native enterprise-grade tools. So we use Ubuntu as our operating system. Actually, you can use whichever Linux distro you like, but we're better able to support you if you use Ubuntu, of course. All the GenAI framework components are containerized using a technology called Docker, which I'm sure many of you are familiar with. And they're optionally orchestrated with Kubernetes. We don't expect people to implement this on Kubernetes during the challenge. Just to be clear, I think that's a little bit too much to ask for. So this gives us a very modular and scalable approach that can run on any modern cloud or on-premise infrastructure. We use Helm charts and YAML as the tools to manage and configure these deployments and do that simply and reliably. So for our database, we currently use ArangoDB. It's a very powerful multimodal database that can handle complex data relationships as well as knowledge graphs, which is perfect for government services. But longer term, we do not want the framework users to be locked into ArangoDB alone, and we'll talk about that a bit more later. Authentication and authorization is managed by a combination of OAuth 2 technology as well as Keycloak. So this provides a robust identity and access management framework. The framework can either run standalone with OAuth 2 authentication or in conjunction with Keycloak to manage third-party identity provider integration. So the roadmap for that includes Google, it includes Facebook, and it also includes what we're doing with the GovStack project. We use a technology called Kong as our API gateway. It doesn't mean that you have to use it. It's one of those components that I feel is quite interchangeable. It manages the communications between the front end and the various different back-end services and does so in a secure, efficient, and monitored fashion. So on the front end, the user experience tier, essentially, our UIs are all built using Vue.js 3. So this is a very modern, progressive JavaScript framework. This allows us to create dynamic, fast, highly responsive user experiences. And of course, it's built on the bedrock of the basic HTML5, CSS3, and JavaScript technologies. The application itself is served by Node.js Express Server. It's fast, efficient. It's really an excellent backend for delivering a good, solid suite of services to any browser-based application. Then the back end, if you like, or the brains of the operation, which does all the AI heavy lifting, is built around firstly, we're using Python as the primary language for this, which is pretty much standard across AI and data science. We leverage Hugging Face due to its vast ecosystem and state-of-the-art open source AI models. We actually rely on LangChain in conjunction with OPEA. This is essentially the framework that lets us connect to LLMs and the government's own data sources. To serve these large language models efficiently and at scale, we use a technology called VLLM. So that's a high-performance serving engine, if you like, for large language models that ensures that all the responses delivered by the engine are fast, scalable, and also cost-effective, which is very important. All the core AI components are managed and orchestrated through an open platform for enterprise AI called OPEA. We'll talk a bit more about OPEA later. So essentially, in a wrapped sense, GenAI is a carefully architected framework built on a modern, powerful, and entirely open source stack. And the choice of these technologies ensures that the framework is not only capable and secure today, but also flexible enough to evolve and adapt as the needs of tomorrow grow. So moving right along, let's get into some more of the technical details. This slide shows our base architecture. It's a logical flow designed for security, accuracy, and scalability. The architecture is based on the outputs of several workshops we conducted in our working group while considering a range of over 30 different public sector use cases across the global South countries. So I'm going to walk you through this by considering the sort of typical user journey of a citizen or a citizen's query, if you like, from start to finish. So firstly, before a citizen can even ask a question, the RAG system needs to contain the information. So if you look at that top section, this is where we prepare that information by ingesting data. This establishes the RAG, or the actual retrieval augmentation part of RAG. So it starts with documents and public services information. So for example, laws, regulations, forms, and official government data. So this unstructured data undergoes curation, supervised indexing, and data preprocessing. We clean, categorize, structure, and label this information to make it indexable by the RAG solution in terms of chunks, vectors, labels, and graphs. So using entity and relationship instruction helps us to build those structures. The process information is then stored in a specialized database, creating a comprehensive knowledge base. So Firstly, it goes into a structured database, which is indexed by labels and keywords. So think about this as like a superpowered traditional search engine that's finding specific documents or keywords. Second, it's processed by an embedding model into a vector database. So this is key for semantic search. It allows us to find information based on meaning and context, not just keywords. Then thirdly, it's used to build a knowledge graph that's stored in a graph database. So this maps the relationship between the different pieces of information. For example, how a specific regulation connects to a particular public service and a particular government department. So this multifaceted approach ensures that when the system looks for an answer, it has a rich context-aware understanding of all the available government knowledge. The actual implementation, essentially we use ArangoDB for all of those pieces we talked about. So the reason we can do that is because it's a multi-model database. And we'll talk a bit more about that later on. So the citizen's journey, if you look at the query side of it, so the actual left-hand side of the diagram. So step one, the citizen would interact with the system via the user interface. They can use voice or text, for example. So we've implemented text for now. We'll talk about that a bit more later as well. If they speak to a speech-to-text model, that model will convert it into text, and the text would then be translated from the input language to English, which is what we're using at the back end for various reasons. I'm not going to bore you with all the reasons for that design decision, but that's the way we decided to do things. So step two would be understanding and safeguarding. So the query text enters the core system. First, it passes through the translation module. So that allows our system to be multilingual. We support all the 6 United Nations official languages and a couple of others. New languages can be added to this framework pretty easily. Next, it hits the guardrails module. So this checks the query for any inappropriate content, policy violations, or potential security risks. It acts as like a first line of defense, if you like. The query is then also sent to the chat history module, which gives the AI context if this is part of an ongoing conversation. So every query itself is not done in isolation. It's done in the context of a full conversation. So for now, that chat history, for various different reasons I'm not going to go into right now, is implemented on the front end. So we pass the full conversation to the back end every time. So step 3 would be retrieval, where the AI-driven search engine magic happens. So the framework searches the knowledge base we prepared earlier. It uses configurable option combinations of keyword-based retrieval, the vector database, and knowledge graphs for a very powerful similarity search to find the most contextually relevant information, or chunks, if you like. The results from these different search methods are then passed to a re-ranker. This is crucial because this component actually evaluates the rank or the relevance of the retrieved information, and then prioritizes the most accurate relevant facts to be answered in terms of the user's specific question. So step 4 is generation. So that's when the user's original query, the labels, the chat history, all the top ranked chunks, and everything in that context are sent to the LLM. So critically, the LLM is not answering questions from its general knowledge. So when I say that, every LLM has a base of training data. And if you ask the same question to an LLM without RAG, it can probably give you an answer. But that answer is not going to be grounded in the more accurate information that is expected from a government solution. In fact, we kind of call that, we definitely call it hallucination. So rather than having hallucination and those synthesized answers that LLMs can deliver, also noting that most or just about all LLMs operate or behave differently in that area because of their training data. We're able to build a much more credible generated artifact from all the inputs. So then finally, we get to the checks and output stage. So the LLM generates the answer, passes that back through the guardrail for a final safety and quality check. Then it's translated from English back to the user's language, and the final step is to send it to the user interface where the original query was made. So finally, none of this can actually happen in a vacuum. So underpinning the entire process is the security system and the infrastructure scalability. So in summary, we built like a modular, robust architecture. It's designed to be secure, to ground AI responses in verifiable facts, and to provide a seamless multi-language experience for the citizen. Every step is deliberate. It's been built from all considerations, including data preparation to the final safety checks. So we've got a link on the slide to the Confluence page with our high-level overview. You can look at any of these links in your own time and fish through. I urge you to do so because there's probably quite a lot of reading to do in order to help you put your designs together. So now let's bring it together with some more specifics. So this slide provides like a high-level summary of the project. It's kind of our at-a-glance view, if you like, covering what the project is and what we aim to achieve and the tools we're using. So we don't want to get, I guess, repeat too much of what I've spoken about already, but in terms of our objectives, our main objective really was to have lower cost commercial performance solutions that deliver sovereign open source alternatives to expensive proprietary AI platforms without sacrificing quality or accuracy. Again, reiterating this, we're focused on improving RAG accuracy. So that's the whole point of the architecture that we've built. And our framework is built for public data tailoring. So it's designed from the ground up to handle complex, unstructured, diverse document types found in government. We've prioritized easy configuration. If you have a look through our GitLab repository, we use very straightforward YAML files and Helm charts, for example, to allow technical teams to deploy and manage the applications very quickly and efficiently. Finally, we ensure AI standards compliance. So there's a very tight collaboration happening between the IEEE and the ITU that really demonstrates our commitment to building ethical, transparent, and responsible AI from the outset. So in terms of key features and use cases, the main feature here, like I said a few times already, is RAG chatbots with multi-language support and doing so securely in an enterprise context. Tech stack, Vue 3, Node.js Express, OPEA, or the Open Platform for Enterprise AI, which we'll talk about a bit more later. So that is the thing that orchestrates the RAG pipeline, as well as the various different pieces that make up the retriever and re-ranking services and so on. And all the structured knowledge, including the knowledge graph and so on, stored in ArangoDB. So I think that covers the architecture in a reasonable level of detail. Please feel free to, once you've got this presentation, click through these links and you can understand a bit more about the repository structure, the code, and the various different components that have gone into it. So there's also some more reading for you on this slide. This is so you can kind of discover the process and the generic design process that went into the architecture decisions, as well as the physical architecture that our MVP has been deployed on. So I'll actually leave this for you to read in your own time. So now we're going to discuss the single most important step in successfully deploying a use case with GENIE.AI, and that's the data analysis and design step. So you just cannot point an AI at a pile of documents and expect good results. The performance of the entire system and the implementation really depends on the quality and structure of the knowledge that we give it. So this is the foundational work that makes everything else possible. Without it, we may as well just pack our bags and go home. So the first step before any data is ingested is really establishing the scope of the knowledge that we need the chatbot to answer. So what precisely do you want this AI application to know? Have you defined the boundaries? You've got to do that. It's going to answer questions. Is it going to answer questions about tax? Is it going to answer questions about law or public health guidelines or municipal services or agriculture or healthcare, as in a couple of the use cases, as well as climate change? So defining that scope is the first critical step. So what I urge everyone to do going through this process with the data sets that are going to be provided by the use case owners is draw that Venn diagram that shows all the intersections between those data and identify any gaps. Because any gaps in that core data could be, ultimately problematic later on. So the process is not just about collecting documents, it's a strategic design of your knowledge core. It involves curating and verifying all the source documents to ensure that they're accurate, ensure that they're up to date. It's like any other system in the history of IT. It's garbage in, garbage out. Very, very simple. So importantly, it also involves creating a multi-level labeling system. So there's a configuration guide here that explains this. It's not just for organization, it's actually what builds the knowledge hierarchy that users are going to see when they interact with the user interface. And also, it helps make the information that's been ingested at the back end more navigable and more relevant for all the users' queries. So there's essentially three tiers of data that you need to think about addressing. Firstly, the primary data sets, or the core of the data, if you like. So that's essential information. It's kind of a must know, if you like, the data that directly answers most of the frequent and critical user queries. So that forms the sort of central circle of your knowledge base. Then there's like a second ring around that, if you like. So the secondary data sets. So these provide the necessary context for answering those questions to get a more complete and elegant response, if you like. So for example, a primary document might state a policy, but a secondary document might explain the exceptions to that policy. So these things are going to overlap significantly with the primary data set. And then finally, we'd have a kind of tertiary data set, which is more peripheral. So this includes more sort of supplementary information that enhances the understanding, but is not essential for every single query. It might be like a background history or related articles or a glossary of terms. It has kind of minor to moderate overlap with the other data sets. So thinking of these tiers it forces you to prioritize and structure your data logically, which directly translates into more accurate and relevant AI responses. So there's plenty of future further reading here. There's a comprehensive README on this, which I urge you all to read. So let's move on. So we just covered the importance of structuring data. Let's get into the specifics of how we do that. So what we've implemented is a new type of labeling. So our solution is a data labeling and enrichment pipeline. This is a crucial distinction. We're not creating training data sets for supervised machine learning, which is another use of labeling that's very common. Instead, we're enriching the raw data before it gets ingested into the RAG pipeline. So the goal here is to embed both semantic and structural signals directly into the data chunks. Think of it as adding a rich set of metadata that acts like a compass for our retrieval system, making it faster and smarter and more accurate. So I could probably get into a lot of detail with this, but I don't think that's really necessary at this point. The labeling strategy is really a part of what solves the core problems of traditional RAG, as well as knowledge graphs. So these are the two things that we have identified along our journey that we felt were very relevant to build into the framework. It reduces false positives by providing a more contextual situation for retrieval. It improves the performance by enabling more efficient targeted searches, and it boosts interpretability because we can now see exactly why a piece of information was retrieved based on its hierarchy, type, and keywords. So for a complete breakdown of the JSON schema for this and how to implement this strategy, I'd encourage you to read through the data labeling strategy. So moving right along, let's do a slightly deeper dive on things here. So at the risk of being a bit repetitive, the UI side is what citizens and government employees are going to see and interact with. So the experience needs to be seamless. It needs to be intuitive. It needs to be adaptable. So this is one of the reasons why we chose Vue.js as the framework. So Vue.js is a reactive component-based framework. It means that we can build the interface out of modular pieces like, for example, chatbot component, which we've given a link to, and a navbar component. So there's a whole bunch of different components in the code base. So this makes the application easy to manage and scale. We use standard concepts like the Vuex store for state management, which is how the application remembers things like your current chat history, selected labels, and so on. So that ensures a smooth conversational flow. There's a whole bunch of key features that are implemented through the framework out of the box. So I mean, realistically, if you wanted to deploy this as a chatbot and just configure it without doing any code changes, you could. But it'd just be a matter of doing the data analysis exercise I talked about earlier. So the core of the experience is the RAG chat interface, of course, and that includes a user interface for data labeling, sidebar navigation, as well as built-in analytics dashboards, monitoring usage, performance, all the administrative functions, and security as well with users and so on. So crucially, the platform is built using multi-language, and we use a standard library called Vue I18N, if you're familiar with I18N, which means internationalization. I think I talked about the languages already. So we support all the UN languages plus Portuguese, Thai, and Indonesian presently. You can add languages easily, and we can show you how to do that. So easy customization is really the most important part, and all aspects of our front end are completely customizable. You don't need to be a developer to do this. You can customize or rebrand the application purely by configuration. So things like the application title, icons, welcome messages, colors, buttons, default prompts, all the languages, the sample questions, the FAQ, the knowledge hierarchy, everything's configurable. So let's move on. So I think this slide kind of is going a little bit deeper into that. So if you want to really change the UI dramatically, we've got everything built into theme variables. So you can actually go ahead and modify the CSS themes pretty readily. So putting it all together, if you want to have a look at some code, obviously we've given one link here to the main chatbot component. There are a whole bunch of components in that repository, all of which I'm intimately familiar with. So please go ahead and have a good look through that as you're building your application proposal. So let's move from the front end to the back end services layer. I think I've talked about this already. It's basically Node.js with the Express framework. So we chose Express Server because it's event driven, it's very efficient, and it handles many simultaneous API requests, which is really perfect for a chat application. So it manages key endpoints like API queries or whatever for handling user questions, or API auth for authentication. Architecturally, we've designed it using singleton microservices. So this means that core functions like handling queries, authentication, and analytics are separate from the self-contained services and they can queue requests. So having a singleton service, I think, is a key architectural facet because this allows you to scale up very easily with deployments on Kubernetes. And we can probably talk about that till the cows come home. But we also use a standardized middleware layer for critical functions like security. We're using JWT tokens to prevent any abuse with rate limiting and multiple. We're doing that in multiple layers as well. So the actual backend is also kind of central to what we're doing to integrate everything through the RAG flow. So the backend app there for the front end, if you like, or the Node.js app would actually receive the query from the front end and store it, then package the whole context for OPEA. It then communicates with OPEA to perform the retrieval step, and then OPEA and its extensions would process that request like we talked about earlier, using that conversation context, and then send that context along with the original query to the LLM to generate a response and then return that response back to the user. So essentially, that orchestrates the whole complex process pretty seamlessly behind the scenes and does so in a security-first manner. Again, I'd urge you to really go through the repository and have a look at this in detail. We'll try and answer some questions if we can on this, but yeah, all in the interests of time. So let's peel back another layer. So I think I mentioned earlier that we're using some middleware. So essentially, what we're doing with the middleware is using an API gateway and also a web server called Nginx as a reverse proxy. So that's really the first line of defense, if you like, for managing all the incoming traffic and securing it and directing it to the right place. So for this, we use that two-part combination, which for us is recommended, but actually you can use whatever you like. So if you don't want to use Nginx and you don't want to use Kong, feel free to do that. Go ahead. So for us with Nginx, we implement it as a reverse proxy. Its primary job is to handle all the incoming HTTPS traffic and terminate SSL connections. So it also adds crucial security headers to every response, like content security policy headers as well as HSTS, and that protects the underlying infrastructure from the common attacks that are so prevalent on the web right now. So most importantly, if you have a look through the default conf, you can see that it acts as a very effective traffic director and serves the front-end application directly to browser clients. It also forwards any requests that because with Vue.js, it's JavaScript. So once it gets loaded into a browser, it then needs to call APIs. So then all the API requests are also forwarded through Nginx and Kong. So essentially, we've got a fairly simple Kong uh, configuration for now. So it pulls all our APIs together into a single interface, and it applies the JWT token authentication as well as rate limiting. So essentially, both these services, like everything else, can be set up using a Docker Compose YAML. That makes it pretty easy to deploy and manage. And everything we've done there is designed to be extensible, and developers can simply add custom plugins or define new routes if you want to through the various different facilities available in Kong. So let's move on to the RAG framework backend. So I might ask Roman to chip in a little bit here. We've built our existing option based on OPEA. So this is the primary option. So OPEA stands for Open Platform for Enterprise AI. This is the backend that we've already incorporated into the GenAI stack. It's our default fully integrated solution. So when you set up GenAI and follow our standard guides, this is the engine you'll be using. It's robust, it's tested, it's ready to go out of the box. So we've got a second option, which has been put together as a challenge roadmap item, which we'll talk about later. And that is deploying Haystack. So Haystack's another powerful open source RAG framework that's been developed by a company called DeepSet. We're presenting this as an exciting opportunity for participants who want to dive deeper and contribute. The challenge is to implement the same features we have in the OPEA version, but using Haystack as the framework instead. So to encourage this, we have a few points. So firstly, there's an incentive, so additional points will be added for successfully delivering this functionality. And you won't be alone because DeepSet's already agreed to provide some direct support for participants who choose this path. So I think there's a fantastic opportunity to work with the creators of the Haystack framework on that. And I think this is a more advanced track, and we'll cover some of the specifics in a little bit more detail later on. Plus, Bilger's here to answer any questions you've got about Haystack. So let's move a little bit faster because obviously time is of the essence here. So now we'll get into specifics of the OPEA backend and how we customize it. So essentially, we've made two pretty key customizations. So essentially, we've rewritten the data prep pipeline. So that is the piece that we were talking about earlier that ingests documents and creates knowledge graphs and does all the entity and relationship extraction and labels all the data at the back end. It also includes customizing prompts in the prompt engine and so on, and ensuring that the LLMs receive the instructions in the most effective way. Then the retriever customization as well. So this is about improving how we find the right information. So we've had the flexibility to develop custom retriever microservices that, for example, query our knowledge graph, use our hybrid search strategy to find the most relevant facts for a given query. So OPEA has a lot of different facilities, and you may want to leverage these things for innovation within your solution, and you're encouraged to. So putting this into practice, there's a lot of different items to cover in this. We've got a fairly substantial deck of slides that will be made available to you. I think after the session, I'm not sure whether they've been actually uploaded into the resource area just yet, but essentially this approach gives us, the best of both worlds. We ultimately want to offer two back-end frameworks as alternatives for framework users rather than lock them into one particular framework. So specifics of how we use OPEA. So essentially, OPEA provides a lot of different microservices, and there's some really well-established examples, like, for example, chat Q&A you can find in their repository. The real power is that these services are containerized, allowing us to pick and choose the ones that we need to compose them into a complete, what they call mega service, or a pipeline that fits our requirements. So in GenAI, we take this a step further because we don't just use the standard building blocks, we've created a couple of our own. So this is where our custom OPEA extensions are built, and where we've built those specialized services for our unique data prep and advanced retriever capabilities, as well as the re-ranking logic and translation needs as well. So quite a number of different things. Did you want to talk through any of this, Roman?
Uh, yes, thank you for the opportunity, David. No, just to echo the points that you mentioned. Indeed, OPEA is an excellent framework, which provides a lot of customization features, and we have tried to use them as much as possible. And of course, we would encourage participants to also propose and develop their own customizations. And as David mentioned, the key changes that we've implemented were around the data prep and the retriever microservice. And this, of course, relates to the fact that accuracy is of paramount importance, especially in the context of public service applications. This is because, you know, a government chatbot cannot, or any government institutions cannot afford their chatbots to provide inaccurate responses to citizens. So really, all the changes that we've made have been focused on maximizing the accuracy of retrieval. I believe part of it was already described in one of the earlier slides that David projected, which concerned the baseline architecture. But just to mention one more time quickly that our retriever strategy, unlike your common retriever in a retrieval-augmented generation application, uses four distinct approaches for retrieving relevant context. So we're combining keyword search, vector similarity search, with knowledge graph traversal. So actually, there is a separate process which takes care of entity and relationship extraction from the documents that we are ingesting into the system. And then this is also further augmented by the labeling system, which David spoke about earlier. This tends to really improve the robustness and the reliability of the retriever workflow, allowing it to return accurate answers even if you are using a relatively small, so a less capable large language model. And I believe when we speak about VLLM, we could also mention about you know, the different options you have as far as the deployable models are concerned. But overall, as David said, there are a lot of opportunities for customization, and there are a lot of opportunities for experimentation, which is really powerful because you know, different use cases or different types of data might require adjustments, and because of the flexibility of the frameworks, you're free to make these adjustments, and you're free to innovate, which I think is really great.
Yeah, thanks, Roman. So in the interest of time, I've probably talked way too much along the way. I'm very excited about this whole challenge, as well as the framework that we've been building over the last couple of years. But I think we just need to move forward a little bit faster. So I talked a little bit earlier about VLLM. You can do your own reading about VLLM. The primary reason we chose this was for flexibility, scalability, and economically serving large language models. So moving forward from there, multimodal database. I think I talked a little bit about ArangoDB. So we've got some links there for you to have a look through the various different artifacts that we created to support your journey with ArangoDB. So we've got scripts to support pretty much everything you need to do, from, you know, backing up databases to configuring the whole environment. obviously creating all the collections that are required and so on, and configuring the schema and so on in the database. We've got a few videos there as well for you to have a look at, to go through ArangoDB. So moving on to deployment, essentially, like I said earlier, all the components are Dockerized, so you can make a choice as to how you want to deploy. We've got Docker Compose files built for various different approaches, so like a 3-node approach or a single node approach, for example. And we're in the process of developing Kubernetes. So Kubernetes will be done with Helm charts. So there's also some other components like OPEA and obviously ArangoDB that have Helm charts built already. So that should ease any Kubernetes deployment going further. We've got a t-shirt sizing architecture as well. So if you get to the stage where you're going to deploy an actual project, then you probably need to think about how to t-shirt size it. So we've got some pretty good guidance on what that's going to take in terms of resourcing. So deep dive on OPEA, we're not going to really do this today. I think all you really need to understand is that it's a microservices model. It handles all the LLM routing and API traffic, and it's designed for customization. I'm not sure whether William made it to the call or not, but I'm sure if he did make it to the call, he'd be happy enough to answer any questions about OPEA during question and answer time. So we're about 5 minutes over time right now, but there's a couple of links for you as well. You can follow to find all the various different artifacts around OPEA. They've got a GitHub repository as well, so you can look through that. Same with Haystack. Apologies, Bilger. I don't have a lot of time to talk much about Haystack, but that's one of the reasons that you're here, to answer questions. So there is a GitHub repository for Haystack if people want to look through it. So there's also a deep dive video that is going to be made available. So thanks a lot to Bilger for providing that for us. We'll be publishing that on the Resource Hub link. I think Roman or somebody else can type the various different links into the chat to get that happening. So now let's get on to the challenge roadmap items. This is what you've all been waiting for, as they say at the UFC. So we've covered all the core components. We've talked about everything with respect to I guess, a fair bit of the detail around the tech, not too much. So for any teams that choose to tackle these roadmap items in their solutions, we're going to be awarding additional credits. So this slide outlines kind of how we're going to be judging those contributions. So quite simply, integration. So how well is the new feature integrated into the existing framework? It should, look and feel like a native part of the system, not something that's just been kind of bolted on. Secondly is quality. So what's the craftsmanship like? How clean is the code? How well documented is it? Is the outcome effective and reliable? So we want high quality professional work. Third is reuse. So great engineering, solves problems more than once. So hopefully your component will be built in a very reusable manner. Fourth is flexibility. So how easy is it to extend that feature? Having a flexible architecture is something that, allows the component to be adapted to new requirements without a complete rewrite, for example. And then finally, adaptability. So is your solution built for just one very specific use case, or can it be adapted easily or configured to solve a whole class of kind of similar problems? So they're the things we're looking for in terms of the actual roadmap items. So this is really the moment you've all been waiting for, the first roadmap item. So the first goal here is to develop a cross-platform native mobile application with GENIE.AI. So this should work flawlessly on Android and iOS. The goal is not just to wrap our existing web app in a mobile view, because we've already got that with Vue.js anyway, right? We're looking for a truly native app that provides full access to all of GenieAI's functionalities with specifically optimized for mobile experience, right? So just think about faster loads, intuitive controls, seamless integration with device features like notifications, for example. So something really cool that people can download from the various different app stores. The mobile app's got to have the same configurable features as the Vue 3 app. So technology-wise, we feel that adopting something like Flutter and Dart would be appropriate for this if you decide to go in this direction. The reason for that is native performance. It compiles to native code. It has quite good reusability for both Android and iOS, which reduces development time and effort, and broad compatibility. So let's move on to roadmap item number 2. So number 2, build a social messaging app integration. So we're pretty open with what you decide to do here. You can look at maybe messaging platforms like WhatsApp, Facebook, or Telegram. So instead of asking citizens to download an app, there's, I think, a lot of value in having this social messaging driven interface. So this should bring government services directly to citizens in a manner that they're probably used to using anyway. Where I live in Indonesia, I know that just about all the people in the villages use WhatsApp, you know. So I think that dramatically lowers the barrier of entry and can massively increase user engagement. So again, you know, this needs to be configurable. Technically, the challenge is to leverage the official APIs that we've got in our platform, as well as leverage the APIs that they've got in, say, the WhatsApp or Telegram platforms. The task is to deploy a conversational agent or chatbot within that WhatsApp or Telegram or Facebook Messenger ecosystem. So it's not really just about simple text responses. The integration should actually expose some of our core capabilities, including, you know, answering real-time queries, potentially handling more advanced features like documents and so on, performing data analysis and so on as well. So the impact to me would be successfully implementing this feature is going to be a potential game changer for digital public services. So hope you're not too scared yet. Roadmap item number 3. This one's a little bit simpler. So essentially what we'd like to do here, and I think this is something that everyone should consider, is build a web plugin. So the goal with this is universal embeddability for GenAI. So it's simple but powerful. We want to create like a HTML tag, say maybe GenAI chatbot as a tag that any developer can drop into their existing website or web app, and that'd instantly embed a lightweight, secure, fully functional GenAI chat interface into their page. So it's not about building a complete chatbot view, if you like, based on what you've seen during our demo already, but having something that's a bit more lightweight and easily deployable. So it needs to have decent user interaction capabilities. It needs to have identity integration. That's crucial. Obviously, it's going to need to manage API keys, then configurability, of course, and security. So the impact of that would be to expand the ecosystem for GenAI. So item number 4, speech to text and text to speech. This is a challenging one. Maybe you want to talk about this a bit, Roman. I know you've got some experience in that area.
Yes, David, with pleasure. There are 2 layers of challenge when it comes to integrating speech-to-speech interface, and one of them is purely technical. So you do need to have the microservices integrated into the overall mega service that we have with GenAI. However, to ease your journey, there are already STT and TTS microservices available through OPEA platform. However, they need to be customized. The more challenging part is having the STT TTS models that support the specific language that you need the application to operate in. And unfortunately, sometimes, especially when we're talking about developing countries, there is a shortage of such models. So you need to either fine-tune them or train them. But I think training is really out of the scope of this challenge because this is too resource intensive. So, however, at the same time, this is a very important feature because it allows for greater inclusivity and accessibility of these AI services. So for those who will be willing to consider and work on it, we would very welcome your contributions. And let's see what the end result could be achieved.
Cool. Thanks, Roman. So we're actually running pretty horribly over time. I'll just quickly go through the remaining 4 items, I guess it is. So the next one will be building a complete replacement backend for Haystack, which we've kind of talked about already. And Bilga's here to answer any questions in terms of what that would take. So feel free to ask us any questions around that during Q&A time. Next is implementing a replacement for ArangoDB, which I think is a very complex task. Now, we've got some sample code there that we've started developing. It has some challenges due to the language compatibility between ArcadeDB and ArangoDB. This one, I think, is something that we'd be very thankful for. It's just one of those items that we feel is technically quite challenging. So I think we probably will be awarding some higher points for some of the areas that are a bit more technically challenging. There's some sample code there. It's in the repository. You can have a look through it. It's been kind of prototyped, but it hasn't been tested and it's not fully functional yet. So there's at least a head start for that. The second to last item, let's call it, is implementing Kubernetes Helm charts. So we've actually got a team working on some of this right now, and you might have the opportunity to interact with them depending on how things go. But again, the goal for this is really to have enterprise-ready deployment on Kubernetes. Some of the work's already been done. There's a lot of existing assets to leverage from OPEA and ArangoDB and so on. We probably really just need to support the sort of large and extra large t-shirt sized architectures for this. And we're prepared to answer any questions around this during Q&A time if you like. So let's move on to the last item, which I think is the scariest one. So we've built a fairly comprehensive agentic workflow specification. Now, regardless of what anyone takes on during the challenge, we're actually intending on developing this further anyway. And I believe that we're going to be working with a pretty major vendor on this. So if you decide to start moving this forward, it would stand you in very good stead to work with us and that major vendor to get some interesting career points. So I think this is a really topical thing to do. It's something that we're committed to, and essentially the critical requirement there is to obviously integrate with some of the GovStack building blocks. So we're looking for something that's pretty seamlessly interoperable with all of those APIs. So if you're not sure where GovStack is, you can look it up on the web. It's pretty easy to see and spell. There's actually a link to the GovStack website in this deck of slides somewhere. So I think, God, we're 15 minutes over. So we can spend as much time on Q&A as you like. Let's go with Q&A.
Okay, great. Thank you, David. Thank you, Roman, for the presentation. I'm going to make sure we have everybody who's able to answer questions available here. And great. So for all the participants here, my suggestion is please to use the Q&A tool. It should be on the bottom bar of your Zoom. It's a little icon that has a question mark and it says Q&A, and we ask that you please send questions through there. And we will receive them. We'll give you just a second to have some thought and send those questions in.
Maybe I didn't scare everybody.
I know.
Perhaps while we're waiting, just a quick note. So the multiple resources have been shared on the slides in the chat during this presentation. Just a quick suggestion that probably the best starting point for everyone who wants to learn about the framework would be the resources that we have on Confluence. And from these resources, you can transition to the many other websites, GitHub repositories, GitLab repositories that we have provided. So please feel free to explore. I think with the high-level information that have been provided to you, you should already have a basic understanding of the key features of the framework, and this should put you in good position to start conceptualizing some of the ideas that you might have for your projects, your solutions under this challenge. And of course, you will have the opportunity to refine them, as you discover more about the framework, and we will keep sharing more resources with you throughout this journey. So please feel free to explore. Thank you.
Oop, I'm talking on mute. Roman, thank you for sharing that. Yes, all the resources that have been shared will be available on the website in the next few days. We do have a question that just came in. The question is is there ability to integrate existing work with GenAI, and would that be considered? That's the first question here. I'll pass it first to David, and you can redirect it if you'd like to.
Sorry, the question was integrating existing work with GenII. I'm not sure what that means.
I will let them elaborate, but my understanding of
Yeah.
the question would be if there's like already existing work, could it be integrated into GenAI, and would it be considered?
Yeah, well, if they've got anything that they've already developed that they think they can integrate with the framework and deliver as part of the solution, we're more than willing to look at that. That's fine. That'd be great.
The
As long
only
as it delivers
important
value in the use case, right?
Exactly. And on top of that, a very important requirement is that any integrations or any of the enhancements that you contribute, they should be open sourced. So
Yes.
they would need to be made publicly available and open source under one of the permissive open source licenses like Apache 2.0 or MIT.
Great, thank you. The next question that came in is, I'm sorry, I'm reading it 1 second. Is it implied that the submission is to build a use case specific chatbot that is expected to reflect the last 8 items? I'm assuming the last 8 items that were shared.
No, not at all. So to be really clear about this, we do expect submissions to build use case specific chatbots, but implementing the last 8 items is an optional thing. And if someone decides to implement one of those 8 items, I'm not saying that you should implement more than one. I think any one of those items is going to be fairly significant in itself. We will consider your proposal more credible and more carefully, especially during the implementation. If you become a finalist and you implement that feature, it would stand you in good stead.
Great, thank you, David. Yeah, so I think if you're able to read in the Q&A, this is an elaboration on the last question, so you can let me know.
Yeah, I can see it. Yeah. So he's saying, yes, own open source work, which would provide live data for the system, live communications via different APIs. Yeah, sure. That's not a problem. So if you've got your own technology you've developed with open source and it provides live data access to different systems and you can integrate that with the framework, that's not a problem for us. Great.
Great, thank you. We'll give applicants another second to respond. As a reminder, the Q&A is on the bottom of the bar on your Zoom.
And maybe in the meantime, I can also give a little bit information about Haystack. So I have already prepared this video for all participants to understand what Haystack is and how they can leverage Haystack for their use case. I think that is definitely a great starting point for everybody. And then they can take a look at the website. Roman sent the link to the chat already, and there you can find the link to the documentation, to all the tutorials and the cookbook that we have. And you'll also find the Discord link there. So if you also have any questions around Haystack, how to build some certain stuff, or if there's like a bug that you are encountering, you can ask those questions to me or any other like people in the community. We would be happy to help you with everything that goes around your application.
Thank you so much for elaborating there. We have a question that is, what is your policy on using AI enhanced development tools? Do you expect all code to be handcrafted?
That's a great question. So this might seem a little bit presumptuous, but honestly, if you're not using AI enhanced development tools, I think you're not doing yourself a very good service. So we'd encourage the use of AI enhanced development tools. I think it's the future, and it's the way that people should be developing code. So I personally don't expect, I think as a team, we don't expect everything to be handcrafted, but obviously when you're building something with an AI enhanced tool, you're going to need to verify and validate that the code meets the requirements, and especially all the non-functional requirements like security and scalability and so on.
Great. Thank you, David. We'll give it just a couple more minutes. I'm also going to send in the chat a location where you can send additional inquiries if something comes up while you're reviewing. We know there were a lot of materials, and so we can make sure that any inquiries you have get directed to the appropriate team member to answer your questions. But we are still live, so we welcome live questions. That's for, as you're pondering, if you have any additional ones that come up.
So it might pay to read back a couple of the questions that you answered in the chat, Antonio, because I think Benjamin Miller asked an interesting question right up front there about the size of teams and how a couple of members could be a drawback or whatever. So, which I don't think we discussed.
I'm answering questions right now that are technical in nature, but there were a couple questions that came in that were not
Yeah.
as technical. I did answer them privately. I responded directly to the individual. Any questions that are unrelated to this technical session, I encourage you to please review our Q&A session that answered some of those questions. It's on the bottom of our homepage. We also have our FAQ. And again, if there's any additional inquiries, we're happy to answer those. But many of those questions are answered in our Q&A. All right, I'm going to give us one more minute here, and then we'll let everybody head on their way for whether it's your evening, night, day. Okay, thank you so much. I will keep this open for one more minute if those who are presenting, if you don't mind just waiting in case anybody lingers. But I think for everybody else, if you're all set, you're welcome to head out. And we look forward to your applications coming in. Thank you so much for your interest in this challenge. We are really excited to see what kind of solutions we have. And David, if you want to jump in to close out here, well, you can
Yep.
have our closing.
So Thank you very much, Antonia. Thank you very much to the team for the very nice and exhaustive presentation. It was pretty clear. I hope that the participants could get most of their answers and start integrating the framework and the various concepts in their ideas. As you can see, it's a rather advanced framework, so we are really expecting innovative and quality contributions to this challenge. So please, if you have any questions, do use the Smartsheet tool that was provided in the chat by Antonia, and let us know any questions you may have. We'll be happy to provide you with any support in building your application. And with this, I do thank you all for your attention, for participating, and to the team for the great work in pulling up this exhaustive presentation. And I'm really looking forward to receiving your applications by the 1st of December. So thank you very much and good luck to everyone.